Okay, this is the third video of the vectors. Already first video vectors, introduction and types of vector we discussed. And second video, how the angle between the two vectors can be forming and adding the two vectors. And third video discussing the laws of vector addition and the laws of vector subtraction. Okay, now how the laws of vector addition is there? Actually, there are three are there. The first one is the commutative law. The first one is the commutative law. Second one is the associative law. Second one is the associative law. And third one is the distributive law. Third one is the distributive law. Okay, third one is the distributive law. Okay, first of all, we need to discuss the commutative law. Okay, already we discussed the previous video, adding of two vectors. Same we can apply here. The first one is the a bar plus b bar is equal to b bar plus a bar. This is the commutative law. Is the equal or not equal? We can discuss that based on the proof. Okay, the first one is diagrammatic representation. For example, a bar vector is there. Okay, how they adding the vector? Head of the first vector is connected to the tail of the second vector. Head of the first vector is connected to the tail of the second vector because of a bar plus b bar. First vector a bar, second vector b bar. Adding, how can we add these vectors? Tail of the first vector is connected to the head of the second vector. Head of the second vector. That's why c bar is equal to, how can you write a bar plus b bar? C bar is equal to a bar plus b bar. Same. It's a same way. We can be see that its a direction is upward direction. Next b bar. B bar is the first vector. A bar is the second vector. For example, b bar is the first vector. Okay. And a bar is the second vector. Head of the first vector is connected to the tail of the second vector. And resultant vector, tail of the first vector is connected to the head of the second vector. That is the c bar is equal to b bar plus a bar. See, the direction is same. The direction is same in the upward direction. Direction is proved. Next, a bar plus b bar. For example, a value 2 and b value 3. A plus b is equal to 2 plus 3 is equal to b plus a. 3 plus 2 means 5 is equal to 5. The magnitude also same. That's why commutative law obeys the laws of vector addition. Okay now. And second one is associative law. Second one is associative law. Associative law. Okay, second one is associative law. What is the associative law? See, a bar plus b bar plus c bar is equal to a bar plus b bar of plus c bar. Okay. Is it obeys the laws of vector addition or not? We can based on the proof. Okay. The first of all, graphical representation and a diagrammatic representation. See the vector notations. We can see the first one, three vectors we need to take. That's a three vectors. For example, like this. Okay, a bar, b bar, and c bar. The first condition is left hand side. First b bar plus c bar, b bar plus c bar. Head of the first vector is connected to the tail of the second vector. What is the adding this one? A bar. See, we are adding like this. What is the value? B bar plus c bar. Head of the first vector is connected to the tail of the second vector. Next one, we can add the tail of the first vector is connected to the head of the second vector. That is called as a bar plus of b bar plus c. B bar plus c. That's the first one. Left hand side has completed. Right hand side, a bar plus b bar. A bar plus b bar. Head of the first vector is connected to the tail of the second vector. That is the a bar plus b bar. What is the resultant vector? Tail of the first vector is connected to the head of the second vector. That is the a bar plus b bar. And next one plus c bar plus c bar. Is it right? Yes. A bar plus b bar plus c. Is it right? In the same direction. Direction is proved. Yes. Next one we can use the magnitudes. For example, a value 2, b value 3, c value 4. We can take it out. What is the value? 2 plus of 3. 2 plus of 3 plus 4 is equal to a bar plus b bar. 2 plus 3 plus what is the c value? 4. 3 plus 4, 7. 7 plus 2, 9. 2 plus 3, 5. 5 plus 4, 9. both are in same. Magnitude is also same and direction also same. That's why it can be obeys the laws of vector addition. Associative law obeys the laws of vector addition. And third one is distributive law. And third one is distributive law. And third one is distributive law. Okay, what is the distributive law? See, for example, constant k, a bar plus b bar is equal to k into a bar plus k into b bar. Okay, see some example. K value, for example, 2, a bar value 3, b bar value 4. Okay, is equal to 2 of 3 plus 2 of 4. 3 plus 4, 7. 7 2s are 14. 2 plus 3, 6. Plus 2 plus 4, 8. 6 plus 8, 14. That's always the magnitudes also same. That's why a distributive law also obeys the laws of vector addition. This is the laws of vector can be obeys. Next one, subtraction of the two vectors. Subtraction of the two vectors. Subtraction of two vectors. Okay, already adding of two vector we know very well. Yes, that's based on the subtraction. We can use the adding of two vectors. See, for example, a bar minus b bar. A bar minus b bar. C bar is equal to a bar minus b bar. Then we can write in other way, a bar plus of minus b bar. We can write, yes, obviously, right? Plus into minus, minus. That's a bar minus b bar. Means we using the addition vector, then we can getting the subtraction also. Yes, that's based on the diagrammatic representations. See, for example, a bar vector is there. Okay, b bar vector in this way, and negative vector minus b bar. Already types of vector we discussed. B bar, what is the negative vector? Yes, equal magnitude but opposite direction. Okay, from this we need to apply here. A bar, head of the first vector is connected to the tail of the negative vector. Tail of the negative vector will be in this direction, minus b bar. And resultant vector, tail of the first vector is connected to the head of the second vector. That's c bar is equal to a bar plus of minus b bar. Means a bar minus b bar. That's why we can write the subtraction of the two vectors. Subtraction of the two vectors. Are you able to understand? Subtraction also we can use the adding of two vectors. That's we use the plus into minus, we'll be getting the minus. Okay. From this we can use the laws of subtraction of the vectors. Laws of vector subtraction. Laws of vector subtraction. Okay, laws of vector subtraction. Okay. See, from these we need to apply the same. First one is commutative law. Yes, commutative law. And second one is the associative law. Associative law. And third one is the distributive law. Distributive law. Okay. Already we discussed that these three laws always obeys the laws of vector addition. But in these cases, subtraction is obeys or does not obeys. That's based on the we had discussed. First one, commutative law. What is the commutative law? A bar minus b bar is equal to b bar minus a bar. Okay, is it equal or not? We can based on the proof. Okay. First diagrammatic proof, we can see it. First of all, a bar vector. Okay, for example, b bar vector will be positive and negative vector b bar is in the downward direction. Whatever the direction you can consider, it will be easy. Okay. And next one, what is the next one here? First of all, a bar vector will be there. Okay. Positive a bar here, negative a bar in this direction. First of all, what is the left hand side? A bar minus b bar. First vector a bar, second vector minus b bar. Okay. What is the a bar for first vector plus? Okay. Second vector minus b bar. What is the minus b bar? In the downward direction. Head of the first vector is connected to the tail of the second vector minus b bar. This is the a bar. What is the resultant vector? Tail of the first vector is connected to the head of the second vector. That is the c bar is equal to a bar plus of minus b bar. A bar plus of minus b bar. We can write like this, or a bar minus b bar. We can write directly. Okay. That is the left hand side. Right hand side, b bar is the first vector. B bar means upward. B bar is upward. What is the minus a bar? Minus a bar, left hand side. Head of the first vector is connected to the tail of the second vector. That's the resultant vector in this way. C bar is equal to what need to write? B bar minus a bar. B bar minus a bar. Okay. By doing this one, see the direction in the one is the upward direction, another one is the downward direction. Means direction is opposite. Okay. But magnitude are same or different. We can discuss now. Directions are opposite. Direction opposite means what happen? It does not obey the commutative law in a vector subtraction. Okay, commutative law does not obey the vector subtraction because of direction is the one is the upward direction, another one is the downward direction. See from this we need to take the values. A is equal to 2 and B is equal to 3. 2 minus 3 is not equal to what is the B minus 3 minus 2. Yes, minus 1 plus 1 is not equal, but magnitude is same. Direction is here only plus, here only minus. The direction is opposite. Then how can you write the in the other way? In a commutative law obeys C. That's easy. What is the first one? C. A bar minus B bar is equal to modulus. Magnitude is same. That's a modulus we can use. B bar minus A bar. That's a magnitude is same. Okay, we can write like this. In other way, we can write A bar minus B bar is equal to minus of B bar minus A bar. Because of already we got the negative direction, opposite direction. That's why we can keep the minus or equal. In these cases, obeys. But actually in the cases does not obeys. Yes or no? Does not obey the commutative law in the vector subtraction. But in this way, it can be obeys. Magnitude means only same. That's why we can write the modulus. And the direction is opposite, that's why keep the minus. It is also right. Okay. That is a commutative law. Next one. Associative law. Next one. Second one is the associative law. Associative law. Okay. What is the associative law? See, A bar minus B bar minus C bar is equal to A bar minus B bar of minus C bar. Is there any proof? Is there? Nothing happened. Directly we can see it is not a correct way to, does not obey the associative law, does not obey the vector law of subtraction. But vector law of addition can be obeys. That's a very important. For IIT and NEET examination also asking the some questions based on this type of questions. Okay. That's what does not obey. Because of already we need to take the values. Because of direction will be different. A is equal to 2. B is equal to 5, C is equal to 3. If you want to take the 2 minus 5 minus 3, 2 minus 2, what is the value? 0. Here only A bar minus B bar, 2 minus 5 minus 3. What is the value? Minus 3 minus 3. What is the value? Minus 6. Those are magnitude also does not equal. Yes. That's why associative law does not obey the Laws of vector subtraction. Okay, next third one. What is the third one here? Distributive law. Distributive law. Okay, what is the distributive law? See, distributive law means already we discussed k into a bar minus b bar is equal to k a bar minus k into b bar. For example, k value 2. This is the 5 minus 3 is equal to a value 5, b value 3. 2 into 5 minus 2 into 3. What happened? 5 minus 3, 2. 2 2 is a 4. Here only 2 5 is a 10. 6. Always 4. Sometimes will be equal. In cases, we can take the in a reverse order. A value 3, B value 5. What happened? 3. Next, what happened? 6 minus 6 minus 10. 6 minus 4, 10 means always minus 4. Here only minus 4. The magnitude also same, but what happened? It can be changes. But distributive law can be obeys the laws of vector subtraction because of getting the same. Yes. Next one. Already laws of vector addition has completed and laws of vector subtraction also completed. Then based on the how it is adding the two vectors and how is the subtraction of the two vectors, we discussed that in the previous class. And the next video also will discuss that's a very important topic is that resultant vector we need to find using what is the resolution of the vector and 2 dimensions and 3 dimensions. That's the next video will be uploading. Okay, if you like the video, you can subscribe and share it. Thank you very much.